Okay, so this video is a continuation of the sequences stuff. And so in this one, we're going to talk about something called arithmetic sequences. So remember, geometric ones were the ones that started with some term, and then you multiplied it by something to get the next term, and then you multiplied it by the same amount to get the next term, and so on. So, but that's geometric. So we're talking about arithmetic here. So arithmetic sequences, instead of multiplying by a certain amount, you actually just add to get the next amount. So the first term I'm going to call A, and then the second term I get by adding something called the common difference there. So A plus the difference. And then A sub 3, I'm going to add another D to it. So I end up with A plus 2D. And then A sub 4, I'm going to get A plus another D. So it'd be 3D. And then if I keep going down to the nth term, then I'm going to get A plus, and then this term is, I've got n minus 1 Ds at this point that I've added in. Okay, so that's considered the general term right here. All right, so let's say, for example, oh, and by the way, this is an explicit definition, explicitly defined definition. So let's just say definition. And remember, explicit means if I give you n, you can just plug it in and get the nth term. Okay. So if for an example I said the third term of an arithmetic sequence is 12, and the seventh term is 35. Let's find the first term, the common difference, and the nth term. Okay, so it's the third term. So remember, third term of an arithmetic sequence. Well, here's my first term, here's my second term, here's my third term. So I know A plus 2D has to equal 12. And then the seventh term, if I kept going, the seventh term would be A plus 6D, and that's got to equal 35. All right, well, let's do some manipulation of this stuff. I could solve for A in both cases, so if I did that, then I'm going to get 12 minus 2D equals A, and I'm also going to get 35 minus 60 equals A. Well, since they both equal A, I can set them equal to each other. So 12 minus 2D equals 35 minus 60. And if I bring the 60s over, I'll get 40 here. And if I bring the 12 over, I'll get 23. And so D, the common difference, ends up being 23 over 4. So there's my common difference. I've taken care of that. Well, let me plug it back into one of the equations that I know here. So A plus 2D equals 12. Well, that means that A plus 2 times 23 over 4 equals 12. And if we work that out, that's going to be A equals 12 minus 23 over 2, because I can cancel a 2 with that 4 and get a half instead. And then if you work that out, that ends up being 1/2, actually. 24 over 2 minus 23 over 2. So the first term is a half. If I wanted the nth term, well, my first term is a half. My second term would be 1/2 plus 1/23 over 4. My third term would be add another 23 over 4. My fourth term would be add another 23 over 4. So my nth term would be 1/2 plus n minus 1 times 24 over 4. Okay, so there's the nth term right there. Okay. And if you wanted to, you could define it recursively instead. This is explicit. I give you n, you can give me what the nth term is. Explicit. If I wanted recursive instead, recursive means you build it from a previous step. recursive. So if I wanted a recursive rule, I'd say, well, the nth term, just take the previous term and add 24 over 4 to it. Or sorry, 23 over 4. I don't know why I turned that into 24. Otherwise, that'd just be 6. There we go, 23 over 4. So this would be a recursive rule. It depends on previous terms. And the explicit one depends only on n. Okay. Hope that helps a little bit. And the next thing that we'll do in the next videos is actually adding up stuff like all of, oh, I don't even know what the list is. It'd be like adding up the first 10 terms of that sequence, and how do you do that quickly? Okay.